Welcome to T1 Academy. In our last video, we discussed about time and distance concept. So today in this video, we are going to discuss one more concept which is related to our same time, speed and distance, that is problems on trains. So this is also very important, students. In almost all the examinations, we can see at least one question from this problems on trains concept. Okay. So before going to the concept and solving the problems, let us discuss some important things which are very important for us regarding this time, speed and distance. Now see here, students, usually in time, speed and distance, what are the terms we have had? Time, speed and distance, right? These are the things which we have had in our time, speed and distance concept. But now here in this concept, we will hear some more new topics like time taken to cross. Time taken to cross. Instead of time, we will hear the word time taken to cross. Okay, and when it comes to the distance, instead of distance, now here we will hear new words, that is lengths of the trains. Lengths of trains. These are the things which we will hear newly in our concept, this time, speed and distance. In our concept, time, speed and distance. Now, first we will understand what is this time taken to cross. See here, students, in this concept, usually there will be a train. It will cross a pole or it will cross a platform or it will cross another train. Okay, what is meant by this time taken to cross means? Now please observe here. Now for example, if this is a platform, assume this is a platform and here I have a railway track in this manner. Okay. Now when the train, what is meant by time taken to cross means? What is the duration means? The instance when the head of the train, assume there is a train like this. Okay, this is a train. This is head of the train, that means engine, and this is the last compartment or tail of the train. Okay, the instance when the head of the train comes parallel with the platform. At this instance, we will start a stopwatch. At this instance, we start a stopwatch. And when we will stop our stopwatch means the instance when the last compartment of the train, this is the last compartment, right? When the last compartment of the train comes parallel and exits with the platform. Till this instance, when it comes in this manner, then I will stop my stopwatch. And then I will say that this is the time taken to cross. Time taken to cross means the instance when it touches, means anyway it will not touch, but when it comes parallel with the platform to the instance when it gets separated from the platform. So that means this is the duration which I will consider as time taken to cross. Time taken to cross. Now tell me, during this time, what is the distance covered by my train? During this time, what is the distance covered by my train? Please observe here. This is the distance covered by my train, right? My engine from here, it is coming to this one. So this is the distance covered here. So later we will see in detail, but for time being, this one is the distance covered and this is the length, time taken to cross means the instance when it comes in. Similarly, time taken to cross a pole or time taken to cross a man, whatever it may be, and the train, all comes under the same category. Okay, next, the same concept, the very next important thing is about the speeds. Usually, the speeds of the train will be in kmph, right? Right. When it comes to the length of the train, it will be in meters. It will be in meters. So in most of the cases, we always convert our speed kmph to meter per second. Meter per second. We always convert it into meter per second so that it becomes easy for us to solve the problems. Okay, why? Because if I convert meters into kilometers, you will get the answer in decimals. So which is very difficult. And similarly, the time taken to cross also will be, in most of the cases, it will be in seconds only. Within seconds, it will cross a person or it will cross a platform or something like that. So then also the time will be in seconds, the length of the train will be in meters. So obviously, we should convert the speed also into kmph to meter per second while solving the problem. But in the question, if they specifically ask what is the speed of the train in kmph, even though you get your answer in meter per second, later we need to convert it to kmph. We know how to convert that meter per second to kilometer per hour and all these things. In our previous videos, we have seen these things. Okay, right? Now, next, here we will have different cases, students. What are those cases, sir? Means the first one is train and a platform. The first case is for us train and a platform or bridge or tunnel. What is the similarity among all these things? platform, bridge or tunnel, tell me students, they are stationary things and they will have certain distance to pass. See, on a platform is definitely it will have some length. When it comes to bridge, definitely it will also have some length. Tunnel also, it will also have some length. And the train will pass through it or beside it, something like that, we will see it. Now, this is a train and a platform. Now, tell me, when I compare train and a platform, how many moving objects are there for me here? Only one moving object. What it is? Train. What it is? A train. So, let me take an example of platform only. Just now, as I have told you, for your understanding regarding that one. So, this is a train. This is a platform. Okay, this is a train. This is a train. Now, please see here. Now, I will, at this instance, I will start my stopwatch, and when I will stop my stopwatch, if this is a platform, when I will stop my stopwatch, I will stop my stopwatch at this position. Okay, till this time, I will record it and I will tell what is the distance covered by my train. Now, tell me, during this time, during the time taken to cross, my train from this position to it came to this position, right? Please tell me what is the distance covered by it? What is the distance covered by my train in this case? What is the distance covered by my train? It will cover its own distance, that is its own length. See here, what is this? This is nothing but the length of the train only. And it will cover the length of the platform. It will cover the length of the platform. So, here the distance covered by my train is equal to what? Length of the train plus length of the platform. So, here in this case the formula, usually the formula for time is what, students? Distance by speed. Distance by speed. So, here time taken to cross, instead of time we will hear the word most commonly time taken to cross. Time taken to cross is equal to how much distance it is travelling? Length of train plus length of platform. So, LP plus LT by what is the object here? Only one moving object. What it is? Train. So, speed of the train. So, time taken to cross. Time taken to cross in the case of train and a platform or bridge or tunnel is what? Length of platform plus length of train by speed of the train. Here LP means length of platform, LT means length of the train and ST means speed of the train, students. Okay, this is the first case. This is the first case. We can apply this one to any case which have some length and a platform. See, I have taken here platform, bridge or tunnel. In all these three cases, we can apply this logic. Time taken to cross means length of platform plus length of train by speed of the train. Speed of the train. Understood? Right? Next one. Next case. Next case is, see here, train and a electric pole. Electric pole or signal pole all are stationary man. Or a stationary man, that means standing man. So, to make it clear, I have written it as stationary man or a standing man. Now, please observe here, students. What in the previous case, it is a tunnel or bridge or platform. Okay, fine. So, now this is just an electric pole, right? That means we will have a electric pole in this manner. Now, time taken to cross means, please observe here, same concept. This instance to this instance, right? This is engine and this is last compartment. This is engine and this is last compartment. Now, please see here, students, this is also the same thing. Now, here what is the distance covered by my train? So, length of the train plus width of this pole. Now, see here, students, usually the length of the train will be in meters. If you check the width of the pole, width, why I am using width means length means it will become vertical length. So, that is the reason. What is the width of this pole? Tell me, students. The width of this pole is, just it will be in some centimeters, or in worst case it will be into some 100 centimeters or 200. Usually it will not be more than that, right? But when it comes to the length of the train, it will be in some meters. It will be in some meters. So, when we see the length of the train, when we compare the length of the train with the width of the pole, it is negligible. It is negligible. Because of that reason, because not only the pole case, students, if we see a man case, see if a human being is standing on the platform, the width will be what? Very, very less when compared with the length of the train. When compared with the length of the train, the width will be what? Very, very less for us. So, because of that reason, what we are going to do here is very simple, students. Time taken to cross. Time taken to cross. See, earlier we have the length of the platform. Why? Because its length is will be in some meter, so we used to consider it. But here we don't have that length. So time taken to cross will become what? Length of the train by speed of the train. Length of the train by speed of the train. Time taken to cross will become what in this case? Length of the train by speed of the train. See students, here we are neglecting the width of the pole or width of the human being. That's it, nothing more than that. Length of the width of the pole by width of the pole or width of the human being we are neglecting. So we simply write time taken to cross is equal to only length of the train by speed of the train. Length of the train by speed of the train. Understood? Right? Now we will see the next case. The next case is for us is train and a train case. What is this train? See, till now in the previous two examples, what we have observed, students? What we have observed? Only one moving object. What it is? Train is the only moving object. Now, two trains. In this case, what is a common thing? Tell me. Both are moving objects. When we have two moving objects instead of speed, now here what we will have? Relative speed. Already we discussed in our time and speed concept. Okay, so instead of speed, we will have relative speed. If two objects are moving in opposite direction, what happens to their relative speed? Their sum will become the relative speed. If two objects are moving in same direction, what happens to their relative speed? It becomes their difference. Their difference will be the relative speed, which we have already learned in our time, speed and distance concepts. In our previous videos, we have already discussed. Please do watch that one, students. There is a special video for relative speed. You can watch in that video why we are taking that plus and why we are taking minus and all those things. Okay. Now, two trains case. Now, see here, students. Two trains. So, both the trains will have some length. Let us assume this is a train 1 and this is some train 2. For time being, I will take that both are moving in opposite direction. Both are moving in opposite direction. Okay. In this manner. Both are moving in opposite direction. Now, time taken to cross means what? The instance when their heads touch to the instance when their tails separated. From this instance, assume this as head and this as a tail. Head and tail. I will use the terms head and tail here. Okay, head and tail. The instance. At this instance, I will start my stopwatch, and when I will stop my stopwatch means when my train 2 comes to this position and my train 1 goes to this position. This is train 1 and this is train 2. So, this is a tail, this is a tail, head, head. So, the instance when the heads touches to the instance when the tails gets separated. Till this time I will calculate the time, and then I will say that this is the time taken to cross. So, in this during this duration effectively both the trains together will travel what distance? Please see here, tell me. Their own lengths, right? This is the length of train 2 and this is the length of train 1. So, here time taken to cross. Time taken to cross will become what? Time taken to cross. Usually what is the formula for speed, time? Distance by speed. Here the distance will become length of train 1 plus length of train 2 by relative speed. Instead of speed, here we will have relative speed. Instead of speed, here we will have what? Relative speed. Understood, students? Why I am writing relative speed? Why? Because here there are two moving objects. Two trains are moving. So, I am using relative speed. So, first we will find the relative speed based on the direction which they are moving, and then we will apply it in the formula, and then we will try to get the answers. Understood? This is the third case. And the last case is what? Train and a moving man case. Okay. The last case is here for us. Train and a moving man case. I will discuss here itself. A simple case only. No need to worry too much. So, train and a moving man case. Train and a moving man. Now, obviously, train is a moving object and the man is also moving. Train is a moving object and man is also moving. So, here there are two moving objects. So, instead of speed, what we will have? Relative speed. And as we have already discussed, we will neglect the width of the man as usual. So, what is the time taken to cross in this case? Time taken to cross will become what for us? Cross is equal to only length of the train by relative speed. Length of the train by relative speed. Length of the train by relative speed. Relative speed. But see here, students, what happens is there will be one special case. I will discuss with you that case in this man and this one only. For example, see till now in all the cases we discussed only their time taken to cross. But in the case of moving man and train cases, sometimes they will say that the man, this is a train, okay, this is the train, and the man is coming in opposite direction, and the length of the distance between the man, okay, and the train is some 100 meters. The train is some 100 meters. Then time taken to cross means, see here students, if they mentions any distance in this manner, we already know we will consider the length of the train, and we should also consider the distance between the man and the train. So in these cases, what we will do, time taken to cross means what time to cross means what we will take here, length of the train plus distance between man and train. We should also consider this one by relative speed. There is no need to consider the width of the man, but if they mentions any distance between the man and the train means, definitely the train should cover its own distance and the distance between the man and the train. Am I correct? So in that cases, if they mentions any distance specially means, we should also consider that distance, and then we should write the formula, time taken to cross means length of the train plus distance between the man and the train by relative speed. Okay, understood? So these are the things which we should know before solving our problems from this problems on trains concept, students. So okay, if you are good in these areas, or if you understand these cases, then quickly we can solve the problems by just applying the concepts in that one. So most important thing is units, especially with speeds, students. Please be careful with speeds here. Why? Because usually the speeds will be given in kmph, and when they ask about the speed also, they will do the same thing. They will ask it in kmph only. So even though if you get meter per second speed, but when you are writing your final answer, please convert that into kmph and then write your answer. And similarly, while solving the problems, if they given you speed in the question, there also they will give the speed in kmph. So before substituting it in the formula, please convert it into meter per second and then only substitute. Why? Because as I already told you, length of the train will be in meters, time taken to cross will be in seconds. So speed also should be in meters per second. Keep these things in your mind. Now we will solve the problem. Now see here, a train running at the speed of 60 kmph crosses a pole in 9 seconds. What is the length of the train? Okay, now see here students, the speed of the train is what? 60 kmph. Okay. What is the time taken to cross here? 9 seconds. We know what is the formula for time taken to cross in case of a man and a pole? Train and a pole. What is the time taken to cross? Time taken to cross is equal to length of the train by speed of the train. That's it, right? Why? Because here we are neglecting the width of the pole. Simple. We are neglecting the width of the pole. So simply length of the train by speed of the train. As I have already told you, please be careful. Time taken to cross is given in 9 seconds. And the train length also is in meters, which are there in the options. So please convert the speed into meter per second. How we are going to convert kmph to meter per second, students? By multiplying it with 5 by 18. So speed of the train is equal to 60 into 5 by 18 meters per second. 5 by 18 meters per second. So 6 tens are, 6 threes are. So this will become what? 50 by 3 meters per second. 50 by 3 meters per second. So substitute in this one, time taken to cross is 9. Length of the train we need to find it by 50 by 3. By 50 by 3. By 50 by 3. So now what happens to length of the train now? 9 into 50 by 3. 3 ones, 3 threes. So length of the train here becomes what? 150 meters. Length of the train here is how much? 150 meters. 150 meters is our answer in this case. Understood? Right? Next question. A train 110 meters in length travels at 60 kmph. How much time does the train take in passing a man walking at 6 kmph against the train? Now please see here, students. First and foremost thing, this is a train and man case. Okay, good, superb, train and man case. Now, whether the man is idle or is he moving? He is moving. He is moving against to the train. That means he is moving in the opposite direction of the train. Does they mention any distance between the train and the man here? No. If they doesn't mention it, it is a general case. Okay. So in the case of train and mass case, what is the time taken to cross? Just now we have discussed. What it is? Length of the train by relative speed. Why? Because here both the man and the train are moving. Okay. And they are asking us, how much time does the train take passing a man walking at 6 kmph against the train? So first and foremost thing, length of the train they given for us anyway, and we need to find the relative speed. Now please see here students, some students will find the, sir already told that to convert the speed into meter per second, so I will convert this speed into meter per second and I will convert this speed into meter per second and then I will write the relative speed. It is wrong approach students. Anyway we want the relative speed only, right? We want the relative speed. So directly what you can take here is, find out the relative speed in kmph and then convert it into meter per second. So instead of converting two values, just convert only one value, that is what? So what it becomes? Relative speed here, they are moving in opposite direction, right? Against means opposite. So 60 plus 6, it will become what? 66 kmph. Now convert this 66 kmph into meter per second. Okay, so what happens to this? 66 into 5 by 18 meters per second. So 6 11s are, 6 3s are. So this becomes what? 55 by 3 meters per second. 50 by 3 meters per second. Okay, now time taken to cross. Length of the train, what it is? 110 meters by, what is the relative speed? 55 by 3. 55 by 3, right? 55 ones, 55 twos, and this 3 will come to numerator, it becomes what? 6 seconds. So time taken to cross here will become what students? 6 seconds. 6 seconds. Okay, don't waste your time in converting 2 units into meter per second. Anyway, here we want the relative speed, not their individual speeds. So always please find the relative speed first and then convert only 1 to meter per second, that is enough. Okay, next one. Two trains 137 meters and 163 meters in length are running towards each other on parallel lines. One at the rate of 42 kmph and the other at 48 kmph. In what time will they be clear of each other from the moment they meet? This is nothing but time taken to cross only. The moment when they meet and the clear of means what? When the engines heads or else heads come parallel to the instance when they get separated. That is the thing, right? Clear means. So this is also similar to our time taken to cross only. Okay, but another way of asking the question. That's it. Now, time taken to cross in case of two trains is what students? Length of train 1 plus length of train 2 by relative speed. Length of train 1 plus length of train 2 by relative speed. What is relative speed in this case? Whether they are moving in same direction or opposite direction? Running towards each other. Running towards each other means opposite direction. If they are moving in opposite direction, what happens to their relative speed? Their sum will become the relative speed. So 42 plus 48, which is equal to 90 kmph. But as I have already told you, the length of the train is in meters. So I will convert that into meter per second. It will become what? 90 into 5 by 18 meters per second. So 18 ones, 18 fives. It will become what? 25 meters per second. 25 meters per second. Now time taken to cross. Length of train 1 is 137. Length of train 2 is 163 meters. By relative speed, just now we calculated it is what? 25. So 137 plus 163, what it becomes students? It becomes 300. 300 by 25. So 25 ones are 25, I will be left with 50 means 2 times. So in 12 seconds that two trains will get separated from each other or will be cleared from each other. Okay, next one. Two trains of equal lengths are running on parallel tracks. Now they are telling that lengths of the two trains are of equal lengths in the same direction at 46 kmph and 36 kmph respectively. The faster train passes the slower train in 36 seconds. What is the length of the train? See, the two trains are of equal lengths. Okay. Now when two trains case, what it is? Time taken to cross, we will take length of train 1 plus length of train 2 by relative speed. So time taken to cross they mentioned, speeds they given, we need to find the lengths of the trains here. Now first relative speed. They are moving in same direction, right? When two objects are moving in same direction, what happens to their relative speed? Their difference will become the relative speed. So their speeds are what? 46 and 36. So 46 minus 36, which is 10 kmph. Which is 10 kmph. If I convert it into meter per second, what happens to this? 10 into 5 by 18 meters per second. So don't cancel it unnecessarily until and unless it is necessary. So 50 by 18, I will put it this one as 50 by 18 only, no problem. 50 by 18 meters per second. Now time taken to cross. This will become what, students? 36 is equal to, let us assume that anyway they clearly mentioned that of equal lengths, right? Length of each train is L. Assume that length of each train is L. So now what happens here? L plus L. What happens to this one? Let us assume it as L plus L by 50 by 18. 50 by 18. So now what happens to the students? 36 is equal to 2L into 18. This 18 will come to numerator by 50. By 50. So now please here 18 ones, 18 twos, 2 ones, 2 twos. So length will become what for me here? 50 meters. So that means length of each train is here how much? 50 meters. Length of each train is here 50 meters. Understood? Simple. Next one. A train 125 meter long passes a man running at 5 kmph in the same direction in which the train is going in 10 seconds. The speed of the train is similar. Train and a moving man case. So time taken to cross will become what? Length of the train by relative speed. Relative speed. Now first relative speed. The train is moving at what speed? We don't know. We need to find that one. In the same direction. So what we will do is, first of all, let us substitute in this and find out the relative speed. Now time taken to cross is how much here? 10 seconds. 10 seconds is equal to length of the train is 125 by relative speed. By relative speed. Now please observe here. What happens to the relative speed here? This will become what? 12.5 meters per second. Relative speed is here what in this case? 12.5 meters per second. 12.5 meters per second. Now the speed of the trains are given in what? kmph, right? kmph. Because of that reason, we will convert this relative speed meter per second to kmph. So to convert that into kmph, what I should do here? 12.5 into 18 by 5 kmph. 18 by 5 kmph. Now please see here, 5 ones 5, 2.5 times is 12.5. 12.5. So 2.5 into 18, what it becomes, students? 18 into 25. Or else you can take it as 2.5 into 18. 18 plus 18, 36 plus 9, 45 kmph. 45 kmph is the relative speed. Relative speed is here how much? 45 kmph. Now, according to the given data, they are moving in same direction, right? They are moving in same direction. When two objects are moving in same direction, what happens to the relative speed? Speed of the train minus speed of the man. So relative speed, just now we calculated what it is? 45. And speed of the train we need to find minus speed of the man is what? He is running at what speed? 5 kmph. He is running at 5 kmph. When that 5 come to this side, will become what? Plus. So speed of the train here is 50 kmph. The speed of the train here for us is 50 kmph. Speed of the train here is 50 kmph. Understood? So based on our requirement, as I have already told you, sometimes we will convert the meter per second to kmph and sometimes we will convert kmph into meter per second. Okay, this is the process. Here anyway we want the speed of the train, so that is the reason I converted the relative speed into kmph, so that it becomes easy for me for calculating. Okay, what if not, what you should do is, if you put this in meter per second, what first few students will do is convert this speed of the man into meter per second, and then you will find the speed of the train in meter per second, and once again you need to convert that into kmph. It is a huge process. Instead of that, anyway directly we want relative speed. So relative speed I converted into kmph and simply substituted here. Okay, right. Next one. Two trains running in opposite direction cross a man standing on the platform in 27 seconds and 17 seconds respectively, and they cross each other in 23 seconds. The ratio of their speeds is. Now two cases are there here, students. With the train 1 there is one case, and with the train 2 there is one case. Okay. So now they are crossing a standing man, right? So train taken to cross will become what? Length of the train 1 by speed of the train 1. Right? When it comes to time taken to cross here will become what? Length of the train 2 by speed of the train 2. Speed of the train 2. Now here, running in opposite direction, cross a man standing on the platform in 27 seconds to cross each other into the ratio of their speeds. They are asking us about the ratio of their speeds. Now please observe here, time taken to crossing was only given. First train is taking 27 seconds, length of train 1 by speed of the train 1. Second train is taking 17 seconds. Right? And they are asking us the relation between speed of train 1 and speed of train 2. Now please observe here, students, we know only the time taken to cross each other, nothing more than that. And they given us one more logic, the time taken to cross each other, they are moving in opposite directions, is how much they are telling. Time taken to cross each other is 23 seconds. The next case. So train and train case. So what is time taken to cross in this case? Length of train 1 plus length of train 2 by relative speed. By relative speed. This is the other thing which we know. No, so now see here, time taken to cross is how much? 23 seconds. That is equal to length of train 1 plus length of train 2 by relative speed. Relative speed. Anyway, they are moving in opposite directions, right? So relative speed will become what? What will be the relative speed if they are moving in opposite direction? Speed of train 1 plus speed of train 2. Speed of train 1 plus speed of train 2. Now please see here, students. You have this equation, you have this equation, and you have this is the third equation. Now you want a relation between speeds. Now tell me what I should eliminate in this one. I should eliminate this lengths. If I eliminate this lengths, then easily I can find the ratio between their speeds, right? So from this length of train 1 will become what, students? 27 into speed of train 1, right? From this, what happens to length of train 2? 17 into speed of train 2, right? So now I will substitute this length of train 1 and length of train 2 in this third equation. So before substituting, I will multiply this one here. So what happens to this one? Please observe here. 23 speed of train 1 plus 23 speed of train 2 is equal to, in place of speed length of train 1, I will write it as 27 speed of train 1 plus, in place of L2, I will take it as 17 speed of train 2. Speed of train 2. So now I will send this S1 to this side and S2 to the other side. So it will become what? If I send 4 speed of train 1 is equal to 6 speed of train 2. So from this, speed of train 1 by speed of train 2 will become what? 6 by 4. 6 by 4. So this will become what for students? 3 by 2. So that means speed of train 1 is to speed of train 2 will become what? 3 is to 2. 3 is to 2. This means just comparing the things. We are comparing the three different cases and just writing the relation between speed of the train and speed of the train 1 and speed of the train 2 here. Okay, understood? Right, the next one. Now, a jogger running at 9 kmph alongside a railway track is 240 meters ahead of the engine of a 120 meter long train. Okay, now please see here, he is ahead of the train by what distance? 240 meters. Okay, running at 45 kmph in the same direction. In how much time will the train passes the jogger? See students, already I told you, when there is any distance which was specifically mentioned, specially means definitely we should take into consideration. If not, we will not take any distance into consideration. Now, time taken to cross in this case will become what? Length of the train plus distance between them. We should also consider this one by relative speed. By relative speed. Now, length of the train it was mentioned, distance between them it was also mentioned. Now, when it comes to relative speed, those are in what? kmph, right? So, please convert it into meter per second first. Same direction, if two objects are moving in same direction means what happens to their relative speed? Their difference will become the relative speed. So, it will become what for us in this case? 45 minus 9. That is what? 36 kmph. As I already told you, we will convert this kmph into meter per second. So, this will become what? 36 into 5 by 18 meters per second. So, 18 ones, 18 twos, it will become what students? 10 meters per second. It becomes 10 meters per second. Now, time taken to cross. Length of the train is how much? 120 meters. And the distance between them is what? 240 meters by 10. That is the relative speed. So, what happens to this? 360 by 10. 0, 0 get cancelled. So, it will become what? 36 seconds. That means the train will cross the man in what time? 36 seconds. The train will cross the man in 36 seconds here. Okay, right? Next one. A 270-meter long train running at the speed of 120 kmph crosses another train running in opposite direction at the speed of 80 kmph in 9 seconds. What is the length of the other train? This is the case of train with a train, right? So, in the case of train and train case, what is time taken to cross, students? Length of train 1 plus length of train 2 by relative speed. And here what they are asking, they given us one train's length, we need to find the other train's length. Let us assume train 1 is given, train 2 we need to find. Time taken to cross was given and the relative speeds are also given. So, first we will find the relative speeds. The long train running at the speed of another train in the opposite direction, right? So, relative speed will become their sum. So, 120 plus 80. This becomes what here? 200 kmph. 200 kmph. So, it becomes what? 200 into 5 by 18 meters per second. 200 into 5 by 18 meter per second. This will become what, students, here? 1000 by 18 meters per second. Anyway, this is not my final answer. I will not cancel and waste my time. So, simply write 1000 by 18. So, now time taken to cross. In what time it is taking? 9 seconds it is crossing. By length of train 1 is how much? 270 meters. Plus we need to find the length of train 2. By relative speed is what here? 1000 by 18. What it is? 1000 by 18. So, when I send this 1000 by 18 to this side, it will become what? 270 plus length of train 2 is equal to 9 into 1000 by 18. 9 into 1000 by 18. Now, please see here 9 ones, 9 twos, 2 ones, 2 500s. So, length of train 2 will become what here, students? 500 minus 270. It becomes 230 meters. So, the length of train 2 is here how much? 230 meters. 230 meters. This is how we are going to find the length of the other train. Next one. A train 800 meters long is running at a speed of 78 kmph. If it crosses a tunnel in 1 minute, then the length of the tunnel is in meters. See, they clearly mentioned in meters here. So, that is the reason he doesn't mention the units here. Okay, don't get confused. Now, see here, the train's length is how much? 800 meters. It is running at a speed of 78. This is a train and a tunnel case, right? So, time taken to cross will become what? Length of the train plus length of the train plus length of the tunnel by speed of the train. Why? Because only one object is moving, that is only train. Tunnel is stationary one. So, they given us, we need to find that tunnel's length. Now, first before that, speed of the train is what? 78 kmph. That means 78 into 5 by 18 meters per second. So, 78 into 5, what it becomes, students? 390. 390 by 18 meters per second. 390 by 18 meters per second. Now, time taken to cross is what? 1 minute. 1 minute means what, students? 60 seconds. So, that is the reason I will write directly 60 seconds is equal to. Length of the train is what? 800 meters. And length of the tunnel, I will take it as LT by speed of the train is 390 by 18. 390 by 18. Now, please see here, from this what I can write? 800 plus length of the train is tunnel is equal to 60 into 390 by 18. 60 into 390 by 18. 6 table, 6 tens, 6 threes, 3 ones, 3 13s. Right. So, length of the tunnel will become what in this case? 10 into 30, 130, it will become 1300. When I send 800 to that side, it will become minus 800. So, length of the tunnel is here how much? 500 meters. The length of the tunnel in this case is 500 meters. So, the answer is here 500. Okay, students. So, this is how we find the answers for this type of questions. Next one. A train moves past a telegraph post and a bridge 264 meters in 8 seconds and 20 seconds respectively. Find what is the speed of the train. Now, please see here, students. Here there are two cases. The train is crossing a bridge as well as it is crossing a telegraph post. Telegraph post. Telegraph post is nothing but a pole. Okay. No need to think too much about it. So, train and a bridge case. Time taken to cross will become what? Length of the train plus length of the bridge by speed of the train. Why? Because only train is the moving one. Similarly, this one also, time taken to cross here will become what? Length of the train by speed of the train. Why? Because here we will neglect the width of the pole. That is the reason we will simplify. Now please see here, students, to know the speed of the train, what we should know? If I take this one, I should know the length of the train. Why? Because here they didn't mention the length of the train. So first, by substituting in this or in this, we will get the length of the train, and then we will find the speed of the train. Now time taken to cross in this case is how much, students? 8 seconds, right? 8 seconds, and length of the train we need to find, and speed of the train we don't know. Here two unknowns are there, so I cannot find any one of those two. Now please see in this one. In this one, what is happening here? Time taken to cross in this case is what? 20 seconds. And length of the train we don't know, but we know length of the bridge. What it is? 264. By speed of the train, still we don't know. That is ST. Now please see here, students. Here, to know the length of the speed, what is our question? Speed of the train. Tell me what it should be, what we need to eliminate here. We need to eliminate length of the train, right? To eliminate length of the train, so what I can write? Length of the train here, 8 into speed of the train. So simply substitute that one in here. When I substitute this value here, what happens to this here? When I send the speed of the train to this side, it will become 20 into speed of the train is equal to length of the train is what? 8 into speed of the train plus 264, right? So when I send 8 to this side, it will become what? Minus 8, and it will become what for us? 12 into speed of the train is equal to 264, right? Next 12 ones, 12 twos is 24, and 12 twos is 24. So speed of the train, what I got here? 22. Please be careful. All the values are in meters and seconds. This is meters per second. Meters per second. But all the options are in kmph. All the options are in kmph. So please convert this into kmph. So 22 into, how you will convert, students? 18 by 5 kmph. 18 by 5 kmph. So 5 ones, 5, 4.4 times is 18. 4.4 times is 18. So 18 into 4.4. 18 fours are, 18 fours are what it becomes, students? 18 fours are 72. 72 and 0.4. 18 into 0.4 less than half. So what you will get? Definitely you will get an answer in decimals, right? Not a perfect value. So there is only one option in the decimals which is more than 1870, that is 79.2. That is 79.2. So we will go with 79.2 here. So the answer here is 79.2. If you multiply also 18 into 4.4, you will get 79.2 kmph only. But generally, to get the answer, you will use that method. Unit digit. 8 fours are what? 32. And a decimal point. So where we have units digit as 2, in only one option, that is 79.2. So we will write our answer as 79.2 kmph. If you have multiple options, we don't have any other choice. You need to find the exact answer. Okay, right? This is how we will find the answer for this one. Next one. Two goods trains, each 500 meter long, are running in opposite direction on parallel tracks. Their speeds are 45 kmph, 30 kmph. Find the time taken by the slower train to pass the driver of the faster one. Not the driver, you should use the word loco pilot. Okay. Now, please read the question and try to understand what case it is, students. Is this a train and train case? To confuse you, he given you train and train case. But actually this is train and a moving man case. Sir, how it is? See here, he is moving in another train. We are comparing the train with the man or the driver of the train. We are not comparing the train with the complete train. We are comparing the train with only one person who is seated in the train. So this is train and a train case, and his movement, see, he is moving, right? Obviously the train is moving means he is also. Earlier cases, the man moving means either he ran or he walked or something like that, right? We have seen. Here his medium of movement is a train, that's it. His medium of movement is a train, but this is not the case of train and a train. This is a case of train and a moving man case. This one is very, very important question, students. You should understand the concept here very carefully. Okay, this is the case of train and a moving man. Train and a moving man. Okay, understood? Right. Now see here. First of all, they are moving in opposite direction. So time taken to cross each other means formula will become what? Length of the train by relative speed. Here the given two trains just to confuse you, but this is the case of train and a moving man case. Okay, now relative speed. They are moving in opposite directions. So their speeds are what? 45 kmph and 30 kmph. It will become what? 75 kmph. So what happens to this one? 75 into 18 by 5. 5 by 18 meters per second. 5 by 18 meters per second. 75 5s are, it will become 375 by 18 meters per second. 375 by 18 meters per second. Now simply I will substitute here. Okay, find the time taken to cross. Length of the train is what? Each train is 500 meters. So obviously the other train also will become what? 500. So 500 by, what is the relative speed here? 375 by 18. 375 by 18. So what it becomes, students? 500 into 18 by 375. You can go with the 25 table. 25 two zeros. 25 ones are 25. I will be left with what? 125, right? So 125 means what? 25 5s are. Next 5 4s are, 5 3s are. Right? Next 3 1s are, 3 6 are. So 4 6 are 24 seconds. That means the faster train will cross the man of the driver in what time? 24 seconds. This is the case of train and a moving man. This is very, very important. This observation is very, very important. Why? Because we are not comparing train and train. We are comparing the train with the person in the, see, sometimes he will say driver, or sometimes he will also say a person sitting in the train. Then also the same logic applies. The person's medium of movement is the train, but that is not the case of train and train. This is very, very important, students. Okay. Next one. A train traveling at 48 kmph completely crosses another train having half its length, okay, and traveling in opposite direction at 42 kmph in 12 seconds. It also passes a railway platform in 45 seconds. The length of the platform is, okay. So here two cases are there, train and train, train and train, and here we have one more case, that is train and a platform. The first trains are common in both the cases. Okay, the train and platform case, what is the time taken to cross, students? Length of train plus length of platform by speed of the train. Anyway, I will take this as the first train. Why? Because we need to find that train's length. Okay, the length of the platform, or we need to find the length of the platform. Now train and train case. Now time taken to cross is what, students? Length of train 1 plus length of train 2 by relative speed. Relative speed. Now see here, they given us a relation between their lengths. Put that aside for time being. Now train traveling at what speed? 48 kmph. Half its length in opposite direction in 42 kmph. So relative speed will become what, students, here? 48 plus 42. This becomes 90 kmph for us. 90 kmph means what we will write? 90 into 5 by 18 meters per second. 18 ones, 18 5s. See, if it is exactly cancelable, cancel it. If not, don't cancel it. So this will become what? 25 meters per second. Okay, and the relation between their lengths is having half of its length. That means length of train 1 is equal to length of train 2 by, or else length of train 2 is equal to what? First train. Length of train 1, if I take it as L, 3L1, then length of train 2 will become what? Length of train 1 by 2. Length of train 1 by 2. So I will substitute all these things in this case. So time taken to cross is what? In 12 seconds. 12 is equal to length of train 1 plus what happens to length of train 2? It is half of first train, right? Length of train 1 by 2 whole by relative speed is what? 25. Relative speed is what? 25. If I send 25 to that side, 12 into 25, 300 is equal to what happens to the LCM? 2. So 3 length of train 1, right? So 3 ones, 3 tens. So length of train 1 will become what for me here? Hundreds, not tens, hundreds. 2 into 100 will become what? 200 meters. It is what? 200 meters. Now I know the length of the train 1. Now the same length is, that same train is crossing a platform of length we need to find. A platform in what time? 45 seconds. So simply substitute the same thing there. But speed of the train 1 is what? 48 kmph. Please convert that into meter per second. Speed of train 1 is equal to 48 into 5 by 18 meters per second. 5 by 18 meters per second. 6, or else directly we can write it as 240 by 18 also, no problem. 240 by 18 meters per second. Now simply substitute in this one. 45 is equal, length of train 1 is how much? 200 plus length of platform we need to find by speed of the train is here 240 by 18 meters per second. Now what happens to this? 200 plus length of platform will become what? 45 into 240 by 18. 9 table, 9 5s, 9 2s, 2 1s, 2 12s and 0. Right? So 5 into 120 it becomes what? 600. Length of the platform is equal to 600 minus 200. So length of the platform here is how much, students? 400 meters. So the length of the platform is here 400 meters. 400 meters. So this is how we need to solve the problems, by taking one case and substituting the values in the other cases. Okay? Right? That's it, students. These are the questions, different questions from problems on trains. In our next video, we will see the different case of boats and streams. Boats and streams, and only these are the cases. Please be careful, as I have already told you, the train and a moving man case, especially when two trains are given. That question will be given only to confuse you by saying two trains. So please be careful with that one. Okay? Right? Thank you very much. We will see in our next session. Thank you.